What happens if the interface to ChatGPT is a knob or a button and not chat?
Super moderno.
This is the question that we asked ourselves with my friend Jose when we were teaching this class at the Copenhagen Institute of Interaction Design in Bergamo, Italy. We created this class to explore what happens when you combine tangible user interface, so something that has no screen, no touch screen, with large language models like ChatGPT, Gemini, Claude, what have you. And the students explore different ways where physical objects with very simple and intuitive interfaces can be made extremely smart by connecting to a large language model or an AI in the cloud. So now we're going to look at the different projects the students built and see what kind of interesting ideas they developed and the things that we discovered along the way.
My name is Jose Chavarria. I'm an interaction designer and faculty member here at the Copenhagen Institute of Interaction Design. These are the results of the Tangible User Interface class that, alongside Massimo and Jose, we teach in here. We put a lot of work in just 2 weeks, which is, I know, crazy. It's a very short amount of time. We start thinking, which are the different things that AI is good about, like pattern recognition, text creation, image generation. Of course, the projects that we're about to show you are not necessarily ready-to-market products, but I think are super interesting provocations. I hope will provoke you too into making some sort of crazy thing to explore how can we work differently with AI. And Nathan, I hope you will enjoy them as well.
This is our project Auracle. We were exploring how we can interact with AI in a new way. It can do pattern recognition, content generation, but we were really interested in its predictive capabilities. And we kind of came upon this idea of the Oracle cards.
Well, this is our project. It's called Curio. The core idea behind Curio was to be able to, understand how we can create something that helps children in exploratory learning. The physical metaphor that we chose was a magnifying glass.
Welcome to Cubit. In this project consists in an interactive device that consists in 2 cubes that, when combined, produce music. Each cube represents a mood and the other cube represents a genre.
Today we're going to talk about our project, which is Sketch Tales. We started it with a very interesting question: is how can we create a bedside lamp that would turn children's sketches into audio stories?
This is our project Auracle, designed by us 3. And so we wanted to leverage AI as a way to sort of bring music and an interactive element of that sort of predictive capabilities of the Oracle cards. So first you let the intuition guide you, pick a card. So I have chosen Inner Power. And what I will do is insert into the cassette player. And when I insert it, it's going to ask me a question.
What gives you the most sense of accomplishment in your daily life? A. Finishing a tough task. B. Helping someone else. C. Learning something new. Or D. Overcoming a challenge.
Think D. D. So when I do this, it will generate another prompt to the AI and respond with a song of my day that corresponds with the answer that I did in my self-reflection and with the Oracle card that I chose.
Eye of the Tiger by Survivor.
So that's basically how the interaction works. So each Oracle card has an RFID tag, and the RFID gets read by a sensor inside the cassette door. And so once the cassette door is closed, that triggers the Arduino Uno Q to send a prompt to Gemini, basically saying, hey, this was the card that was chosen. Generate a question for me that helps the user self-reflect on that theme. And then once you received that question back, it gets displayed here on this e-ink display. And the user can interact and choose their selection using the lettered options. And from that, we send both the question and answer as well as the card that was chosen with a new prompt to the Gemini API. And we receive back a song that is chosen. And then from the song, we do a call to Deezer to play that chosen song.
Going back in time, We actually started with this, our first 1 hour prototype. And it was a cardboard, very fast model. You can see we started with a smaller display than the e-paper and with a slider. We went to the second prototype, in which in this case we consider specific buttons that will have a more direct answer. And we start exploring the mechanism of a cassette. And this is where this third or fourth prototype came to the picture, in which we brought the display to the front and we also add the light feedback.
For this prototype, we had the buttons here and they felt very disconnected toward the layer that is the interaction. So we tried to test other buttons, and because we had the cassette player as a metaphor, and also how can these buttons be like.
One extra detail is that for us, the cassette element was so important.
These ladies, they weren't up for easy. They really want them to get the cassette thing right. And internally, Massimo and I were telling them, hey, don't worry, this is good enough. We were internally like, please, 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 go further. And they did. And they spent like 2 days just working on the right feedback from the cassette. It's one of the things that I wish you could see in the video, like how it feels is really great. I'm really glad they pushed themselves in that.
Okay, so examining a little bit of what we've got going on in here, this is the Arduino Uno Q, and it has a protoboard shield on top of it that we soldered to connect all of the different components. So like the potentiometer knob, the buttons, the micro switch, the RFID reader. Yeah, so this is the Arduino Uno Q, and we have another kind of layer on top of that. And then here we have, this is just like a USB port that allows us to have an aux line in and the power source. And so the aux line in right now, that will connect to our speaker over here, which is kind of a speaker that we just hacked apart, which actually kind of interestingly has an optocoupler so that we can control the speaker button through the code on the Arduino Q, which is kind of a fun thing. And then hidden in our cassette box here is the Arduino R4, as well as the RFID sensor. And we have the lights here and the e-ink display here.
Yeah, so this is it, Auracle.
We made this lovely device. It's called Curio. Curio is an exploration on how kids can use AI in a very tangible way to explore and look at the world around them. The idea basically started when we were thinking about how we can use AI in a very tangible way, not go back to, these chat interfaces that we see every day. To get to this final product, we went through a 2-week rigorous process of prototyping, testing, listening to feedback, and it all started with this first prototype that Pedro is holding up. And yeah, we were looking at how kids can look at things through different personalities. How are they going to hold it? Should it have one handle or two handles? And where will the buttons be? And then we moved on to other prototypes. But this was one of the prototypes in which we 3D printed for the first time, and we were looking at attachable lenses. And this is the final prototype. This comes with 3 magnetically attachable lenses. So one is for history, one is for culture, and one is for science. So these lenses are pretty cool because they have these magnetic pogo pins and a resistor soldered behind it. Basically, the change in voltage when we attach this lets Curio know what lens is attached, and we have all the coding for the lights. Every single lens has their own set of lights, and that's how it understands when a lens is attached or detached, and it does that for every single lens. Now, behind the scenes, inside Curio, we have a speaker, we have a button, and we have the Arduino Uno Q, which was quintessential to our whole project because it's a microprocessor, so it can do all the AI things, and a microcontroller, so it can control the LEDs and the button and everything in one go. So we didn't have to use multiple boards, it's just one board. So when we press the button, it takes an image and from the camera that is here behind it. And this camera is able to send this image to NA10, which is a workflow creator. We set it up to identify the 3 lenses and send the image to Gemini. Then it identifies what is in the image, finds out the facts about it. Then it goes through another AI model that is able to convert the text into voice, and we get the voice back. And that's kind of how Curio works. It's pretty simple, but it feels like magic to kids. Let me show you a quick demonstration. Can we keep this apple here? And I'm just gonna simply point and shoot. So I'm gonna look at the apple, press the button. So now it's thinking. It's basically sending the image to the model, and the model is thinking about 3 facts that it can tell the child.
This is an apple. Apples are grown in many countries around the world. In China, apples are a symbol of peace and good luck. Bobbing for apples is a fun game people play, especially in the United States and England.
So that's kind of what it is. Yeah, we had a couple of fun sleepless nights preparing this. Overnight prints. Do you remember the time we had to sleep here?
3 a.m.
At 3 a.m. Yeah, I think also fitting everything in such a lean form.
Those guys, they really wanted to put everything in a very small place, which at the beginning, Massimo and I were like, guys, don't worry, this is just a prototype. If you need to make it big, make it big. Kind of internally, we want them to make it small. And thankfully they did, but that means that things like the camera, we have to strip the camera component from a different camera out, have to find different adapters for the Q to also get the power, but also take out for the audio. It was a really interesting process to see, and I think the result was pretty interesting.
But all in all, it was a lot of fun, and I think it was a blast. The most satisfying part of it was seeing a kid use it, and when they take it around and look at different things, point at different things, and then click a picture, and then listen to Curio like it's actually talking to them. Yeah. And I think that's the beauty of it, because that's what it was meant for.
Funny because it's like we all shared this memory as a kid when we were like trying to come up with ideas, and we all got like this same memory of just holding the magnifying lens and going around exploring the world. I think it's just beautiful what we managed to build with this.
Okay, thank you.
Welcome to Cubit. In this project consists in an interactive device that consists in 2 cubes that when combined produce music. Each cube represents a mood and the other cube represents a genre, so that the person can choose which style, which atmosphere they want to hear into the music.
So why Cubit? We thought about this situation when people is in a party and someone is playing music and suddenly someone takes over the playlist, right? And there's only one person choosing the music. So this idea of how can we make that situation playful and also open for more people to participate. And we had this idea of the Rubik Cube as a metaphor because it's something you have in your hands, you can move, you change it, usually something that a lot of people can relate.
For example, we can use pop and chill, or salsa and soulful, rock and energetic. It has different styles. A Cubit works with an Arduino. In this case, in one of the cubes there is an Arduino Uno Q, and in the other there is an Arduino R4. In the Arduino Uno Q we have this microcontroller and microprocessor, which is the microprocessor is communicating with Arduino R4 in order to receive the position of the faces. For that there is a sensor of movement which tells which face which position the cube has and which face it has also, and in which face it's attached to a mood or a genre. This information is passed to the microprocessor in an Arduino Uno Q. And then the microcontroller of the Arduino Uno Q also communicates with a microprocessor to say which phase, the same mechanics. And also, it's very important that we have like a feedback with lights. So whenever there is the cube that is stable for 3 seconds, the lights pass from blue to rainbow color. In order to think, it's going to think about which music is going to be reproduced. and it's going to go to cloud to look for a prompt that is going to tell which is like the description of mood and genre the user has chosen, and then this description is going to go to Spotify, and then the playlist is going to be reproduced.
It was very funny because in this team, these ladies were like, always finding different problems with how to deal with the lights, deal with the sound. And they were coming up to Massimo and I, like, we found this problem, can you help us? But they work super fast. So like, as we were finding the solution, they were also coming to us like, hey, don't worry, we just find how to fix this. And we were so proud of seeing how our students, who were people not necessarily with a background on electronics or programming, came up with these beautiful solutions that I think added a lot to their project.
This is our final prototype, but we had 3 prototypes before. We thought about how to connect the cubes with each other, and we took the challenge of trying not to have buttons, for example. So that's why the cubes are connected through a magnet, which actually turn them on and turn them off. Important thing is, like, for example, one of the boxes have an Arduino cube, it has a speaker, it has a battery, and 4 lights for LEDs. So we needed to find a way how to fix everything inside the box.
At first, the batteries that we were using were much larger. They were like basically the size of the box. And so they were used only on the exterior of the box, but in order to have the effect that we wanted to look like it was sort of magic, we had to figure out a way to have a smaller battery, which we had to create ourselves in order for them to be inside the boxes.
It's like when we connect the cubes are on and they will choose the faces that are on top and the music will start. Let's say we want to change it.
So imagine yourself in a party, not needing someone, just one person choosing all the songs, but more something that is an experience where everyone can choose a song based on the mood and the genre that they want. Also, it can be used by myself. I can be in my house and want to listen to some music, and I can use it in a way not using screens all the time, but more in a tangible way.
We really wanted to present like a provocation of moving out from screens to an experience.
Yeah.
Maybe something interesting is that we are from different backgrounds, so it was the first time that we were working with an Arduino cube. We were, using 2 different coding languages because we were also working with the R4. So it was very challenging, but also fun to do that.
Today we're going to talk about our project, which is Sketch Tales. Of course, we've used Arduino Q as the microprocessor in the system. We started it with a very interesting question: is how can we create a bedside lamp that would turn children's sketches into audio stories? We felt an age from 7 to 10 is a very appropriate one because they can understand the language, they can comprehend what an AI is telling and how it would work for us. Yeah, we have the sketch that will be drawn and kept by the kid. Once they keep it over here, the Arduino takes a picture and sends it to the API, OpenAPI, and OpenAI gives us response back with the audio to us. So
it was very challenging at the beginning because most of the image recognition systems, they are made for things that are, real life. But when it comes to recognize a children drawing, it wasn't that easy. These guys spent countless hours just finding the right model to work with until they eventually got to the right model. It's super funny because also the way they tweak how the story works. If the image that they recognize is not exactly what it was in there, kids also find a way to, see those images in there. And I think the concept is beautiful, and I think the result, you'll find it very nice.
So let's just do a quick demo. Priyanka, why don't you draw something for us? Great drawing. Let's put this in and see what is going to happen for us. This is how we initiate it. We need to lift it and keep it. This feedback from the light is giving us that the image that's been captured has moved to the OpenAI API, and we need to wait for the response to come back. This is the audio feedback that comes in when we get the audio back.
What a delightful drawing. Your imagination is full of life, with a friendly dog and a tree full of juicy apples. Wonderful. The curious dog and the apple tree. Once upon a time, in a sunny garden.
This is the whole demo, but we did not come to this point without the steps and how we went with.
So we started with an 1-hour prototype, and while doing that, we realized that it will be best for us to go ahead with that kind of a bird shape, because kids relate to it more than any other geometric shape while interacting with a product. We did not want to include screens in this product, so we faced that challenge where how to include the visual feedback of when the camera clicks the photo, when it's processing, and then when it gives the output. So we decided to include the LEDs in here.
Similarly, how we went with different iterations of the structure, we also went with different iterations and different APIs that we used to come to the point where we are. When we started it, what we did was the image capture was done by Arduino ES, and what we did is we sent it to Claude. Claude gave us the feedback in the form of text file, and we used that with 11 labs, the text file, and moved it to 11 labs to get a very real-time voice and feedback from it and get the output from the text-to-speech model from 11 labs. Once we got that, because the format was in WAV, we had to use Cloud Converter API to convert the WAV file to MP3 file and then use it to play in Arduino Q.
Once upon a time, in a sunny garden.
We also felt the time was a lot. What we saw was that OpenAI has a text-to-speech converter which is in MP3 format, and I was like, great. And we moved it to that. A very interesting thing that happened was that when we presented this, a kid came and drew an image of Hitesh.
This kid came, little girl, 7 to 8 years old, and then she drew my sketch. This is for you. And that was a very hearty moment. I was like, wow, we worked so much to get an output or a expression out of children, and this was sort of an expression of gratitude. So it was a very wholesome sort of a moment for me, for us.
But do you also remember the drawing that Michael made?
Yeah, I remember he drew a completely generated story of a universe through a data visualization chart. So it was very interesting to see how AI can interpret different drawings that kids make or even adults make into like a whimsical world of its own. That exactly what the entire idea of the project started with.
And a very natural progression that we saw was, we're using a sketch currently. What if we use toys? Say, imagine I come in and keep a Spider-Man, and then we get a story based on Spider-Man. That would be a very natural progression, which I feel we can work on and get things done over here. Yeah. Thank you.
So I hope you loved the projects as much as I love teaching the class. If you consider that these are very smart people that don't have a lot of background in electronics and software, so they learned everything during the master program. The class is only 2 weeks long, so they had to invent the product and building a functioning version of it in 2 weeks, which is a lot of work. So I think you have to consider these are student projects, so they're not meant to be final products or things that go on the market, but they are important tools to explore interfaces and discuss, is this the right direction that we're taking with interfaces and AI? Are there different ways that we can do things? So these projects are tools for exploring and figuring out if there are directions we're not taking, things that we can do better. So follow us, like this video. We're gonna make much more projects with Arduino Uno Q and the Arduino App Lab. So see you in the next video.